By the beginning of the 21st century, scientists investigating how Yellowstone was made had images of what lay under the park. But there was a problem. Technology only allowed a view of a few miles below the surface. Then, as more and more data was fed into more and more powerful computers, there was a breakthrough. In April 2006, geologists published new diagrams of hot structures far deeper under the park, and computers painted more detailed pictures. The results were startling. Investigators saw for the first time the sleeping monster that lies below Yellowstone Park. Snaking down hundreds of miles into the earth, far deeper than the relatively shallow magma chamber, is a colossal volcanic pipe. Nobody's certain how deep it goes, but they can picture it down to 400 miles or more, twice the distance between Washington and New York. Smith makes an educated guess about what the underground plume is like.
Our best estimates now, as we start doing the physics and the dynamics of these things, it's like a conduit of melted rock, like a chimney.
That chimney, called a hotspot, pumped up enough heat to melt the rocks of the crust and fill the overlying magma chamber, which then erupted to blast out Yellowstone's vast crater. Understanding how the crater formed was an important moment for the investigation, because there was evidence that similar eruptions had happened before, many times before. Throughout the 1960s, various teams of geologists studied the Snake River Plain to the southwest of Yellowstone Park and found traces of ancient volcanic craters. The crater rims had long been eroded, but their outlines were confirmed by aerial pictures over the following decade. They ran in a straight line along the plain, heading for the heart of Yellowstone Park. On average, each crater was a couple of million years older than its neighbor. Investigators realized that these are the remnants of earlier supervolcano explosions, an unbroken chain stretching far back into geological history. It seemed clear that time after time, the hotspot had blasted out a super eruption and then moved on. The hotspot appeared to have traveled hundreds of miles. But that posed yet another riddle. How could a hotspot, anchored to the core of the planet, be moving? An important clue had been found in 1985 by American volcanologist William Scott. An important clue had been found in 1985 by American volcanologist William Scott. He realized that plotting the location of 30,000 earthquakes around Yellowstone produced an amazing pattern. The quakes traced out a giant V-shape on the surface of the Earth. The V-shape wrapped around the hotspot's location. It seemed at first to confirm that the hotspot was still moving, rippling up the land around it with fault lines and tens of thousands of earthquakes. But the real answer, and earlier craters prove regular super eruptions over millions of years, all of which leads to the most frightening question of all. When will Yellowstone erupt again?